right, good morning, everyone. My name is Christoph Hellmann Santos, and I am the program manager of the European branch of the ROS-Industrial Consortium. I'm very happy to welcome you all to this year's edition of the ROS-Industrial Conference. And we have been organizing ROS-Industrial Conference here at Fraunhofer IPA for 8 years now. And this is actually our first virtual one, so we're really hoping that everything goes right. And we would have been very happy to have you here in Stuttgart this year, but due to pandemic circumstances, it was not possible. But maybe it is not all that bad that you could not come here because, well, Stuttgart in December is not really beautiful, at least also in this year where we don't have the Christmas market. So let's just look at this picture, which is shot in nicer weather. So normally we would have welcomed you here at Fraunhofer IPA, and hopefully we can do that next year again. Tomorrow you'll hear a little bit more from my colleague Werner Kraus about what we do here at Fraunhofer IPA in robotics. But today I just want to introduce you to our team that has made this conference possible. So this is actually the team, and you will get to know more of them in the next days as session chairs, for example. I also want to thank, well, the strong community backing that we have for this event, especially the ROS-Industrial Consortium, as well as the ROSIN project, from which we will also hear a little bit later in this session, and also for AWS for sponsoring the prizes for the ROS video competition that we have running. Thanks to you all. And before we start into this conference, I also wanted to make you shortly aware of the chat function. I think a lot of people have already noticed that here on the right to the window. And also you see there's a question section. So if you have questions, please post the questions in that section. Then we can know essentially what are the questions that you want to have answered. And on the top right, you will also find the polling section where we have actually posted some polls, and we would be really happy to have you answer these polls to give us some information and also something that we can discuss afterwards. And yeah, that is actually that I wanted to say about the tools. Something else I wanted to mention about the conference itself is that we also have some visitors. We have planned in some time at around noon where you can visit the exhibitor booth. Please do that. They have many interesting videos and many interesting information, and there are actually also live demonstrations going on with ROS software running on real robots live. And also, I wanted to make you aware that we have during lunch break a networking session with the wonder.me tool. So please join us there. It's a fabulous tool for really networking via virtual. So that's really cool. I hope to see you there. And now let's start into the conference with a perspective on ROS-Industrial in 2020. And first, let's take a look at what are typical applications in robotics. Well, today, most robot applications will focus on repetitive and relatively simple tasks in high volume production, essentially what we encounter in automobile industry or electronics industry. For example, this would be in manipulation, pick and place tasks with the same objects and positions all over again, or in intralogistics, it would be following the same line all the time. But what about more complex processes with low volume and high variance, such as, for example, low volume seam welding, where, well, your seams change, your workpieces change, or low volume sanding, where you have new workpieces all the time. Navigation and production environments, and I mean here free navigation, not line bound, as well as where you will then encounter humans on the road, or you would encounter boxes or something that is in your path and you need to change the path and these kind of things. Or going for kitting applications where you need to pick things from boxes and put them into kits, kits that might also change. Picking fruits, textile handling, or sorting arbitrary objects. And there are many more of these examples. And this is actually where few robots have gone before. So this is land for pioneers. You could call it the final frontier of automation if you want to. So the question is, how do we help pioneers to succeed in conquering the final frontier of robot automation? Well, what do we know about pioneers and pioneering? So being a pioneer is lonely because there are just not that many pioneers out there and working in robotics. And also being a pioneer is hard because, well, you try new stuff and that works sometimes, but most of the time you will not have that much luck. So this is where ROS actually comes to the rescue. So the robot operating system makes the life of pioneers in robotics easier by providing an open source framework, tools, functions, and functions to build complex robot software. On top of that, you have an ecosystem of existing open source components that have been provided by other pioneers that help you solve your problems. And how to battle loneliness in pioneering? Well, there, ROS is actually helping by creating a common and extendable language, more or less. So this way, ROS helps pioneers to create an open source ecosystem of new algorithms, tools and software packages, hardware support for robots and sensors, and new robot applications. And the ecosystem actually helps creating a community with totally different kind of pioneers in robotics. So today we have people from different kind of places really contributing to ROS. So for example, from schools, research organizations, universities, software developers, hardware suppliers, system integrators, end users, and hobbyists, for example. And there are many more different kind of stakeholders that are actually helping to build ROS and the ecosystem. So the question here is, does this actually work? And does it have an impact on the robotics community? Well, convince yourself. So this all started in 2007 with the first commit from Will Garage and the first open source ROS release in 2009. And in 2012, we conceptualized the ROS-Industrial Consortium, and with a goal to spread ROS also to the industrial applications. And in 2017, we've had the first release of ROS-II. And today in 2020, we have actually, according to a recent paper that researched ROS packages on GitHub, we have more than 80,000 developers that have worked with ROS and put their stuff or their developments public, and more than 200,000 packages publicly available on GitHub. So I think that are actually quite some interesting numbers. And there are actually a ton of new robots using ROS. So we have delivery robots, drones, four-legged robots, underwater robots, warehouse robots, healthcare robots, vacuum robots, and all these kind of robots that use ROS. And then you say, okay, but this is not industrial automation, right? Well, what about industrial automation? Let's take a look at the current situation in industrial automation. Industrial automation has a long history compared to other application sectors in using robots and a very established robot manufacturer market. There are many robot manufacturers on the market, and many of them have their own programming languages and interfaces. And it is not really in their interest to create something common for all robots, which would help us pioneers in actually deploying our software to different kind of robots. So the vendors actually profit of this kind of fragmented programming ecosystem, because actually when the customer buys a robot, he learns the programming language of this robot, and this way is, well, needs to stick with the same vendor to not need to learn another language. And this actually leads to most robot applications being written from scratch for every new automation cell, for example. And this is okay if you plan for high volume production with really long production times without any changes to your production setup. In this case, you can really invest a lot of money in writing a new program for every cell because, well, the cell stays there for 7 or 8 years and it does the same thing all the time, and this will still pay off in the end. But what if you think about highly flexible production, or if you think about low volume production? Then you really run into problems with this traditional programming of robots. And a lot of questions pop up, which cannot really be answered in the current situation with traditional robot programming. So for example, how do you actually build complex and adaptive flexible robot applications for low volume or highly flexible production? software that we can reuse on any robot? And how do we actually control robots of different vendors? Well, that's to the technical part, only some of the questions. And about the economic questions, is creating new robot programs for every new robot cell really economic? I mean, this means investing a lot of time into programming each cell. And how can we actually establish a manufacturer-independent robot software industry, that an industry that offers problem-specific software and not robot-specific software? How do we actually avoid monopolists for robot software in robotics? I mean, we see that tech giants like Google and Apple practically reign the market for smartphones, or Microsoft is actually reigning the market for PCs. On the one hand, this is bad for competition. And on the other hand, this actually makes us as Europeans dependent on these tech giants. And that can create problems in the end. And I personally prefer the open source approach that, for example, Linux or ROS take. Another question is, how can we actually trust autonomous robots that we will see in the future with closed code? And how do we know that they were programmed ethically? From experience in the past, we know that companies that have a closed source model will fight until the last tooth, until they release their code for review, even if it's practically proven that the code is unethical. Examples for that is, for example, the university admission algorithm in France that had some strange factors in there that would then make rich people or rich students profit to be more, or to make it more easy for them to go to universities. Or you see the same actually in Germany, for example, with the Schufa algorithm, that's a credit bureau for the non-German people that judges solvency for natural persons, where we actually do not know what they do with data. So that's actually some of the questions that pop up when you think about these kind of new and intelligent robot applications. And there, I think one solution to these questions could be creating an open source alternative to traditional robot programming. And that's actually what we are doing with ROS-Industrial. So by building on ROS, we are fostering an ecosystem of new algorithms for example, motion planning or path planning, tools and software packages for software quality, system integration, error monitoring, interoperability, and many more. Hardware support for example, robots and sensors. And we are also working on applications such as scan and plan and manipulation, and also intralogistics. To get there, we actually founded the ROS-Industrial Consortium in 2012. Today, we are globally operating and company-backed, and an open source initiative with branches in Asia, America, and Europe. And we have approximately 85 organizations as members. And there are, as you can see here in our nice member collage, startups and international giants, as well as totally middle-class companies in the consortium. In Europe, the ROS-Industrial efforts are supported by two actions, actually. So we have the private action, which is ROS-Industrial Consortium, backed by companies. And then we've had, for the last 4 years, the huge advantage of having a publicly funded project, which was funded by the European Commission, which my colleague Carlos will present in a minute. So this project was called H2020 ROSIN. And are we actually succeeding in building an alternative to traditional robot programming that enables pioneers to build better robot software? Well, today ROS holds a number of advantages for developers of complex robot software for industrial applications, such as, for example, being able to use modern programming languages such as Python, Java, or C, C++ for programming your robots. And when you use ROS, you typically create reusable packages that you can reuse also in other applications. And you have the option of diverse operating systems on which you can run ROS, for example. So today you can run it on Windows, Linux, Mac, and also a number of real-time operating systems. And you have the possibility of easily integrating other libraries, for example, OpenCV or PCL for image recognition. You have a number of drivers for sensors, robots, and everything else that you need. And you have the possibility to actually use standard developer tools. So you're not reliant on an IDE that has been provided by a robot manufacturer that might be outdated since years. So you can use compilers, IDEs, and anything that you want to develop. And the biggest advantage, most probably, is that you can also use modern software quality tools, such as, for example, continuous integration and continuous deployment to check the quality of your application in the end. And then the question is, does this actually have an impact on industry? So we are actually currently feeling that the walls around industrial applications are crumbling, and that we today have answers to most of the questions that are coming from industry. So some of the questions that we always get is, what about licenses and copyleft? So ROS is open source, right? So it must be bad. So you need to lay open your proprietary code. But actually the answer to that is quite simple. So we are using, or ROS is actually based on only permissive licenses. So you can keep your own code private if you want to. Well, the thing is that ROS works with the community. So if you create something that is worthy for the community to use, please contribute it back to the community. And another question that we often get is, what about real time in ROS? I then often ask, how fast is your control cycle actually? And what kind of jitter can you allow? And a lot of applications can already be solved with what we have right now in ROS-I. And later today and tomorrow, you will hear actually from Bosch and FZI that will talk about their experience with ROS-II and real time. So there you'll see that things have progressed a lot on this front. Another question we then often get is, what about Windows? Can I use ROS on Windows? Well, today it's Windows 10, and Windows 10 is the only supported version of Windows today. And actually, it already integrates Linux. So with WSL, you can already run a lot of the functionalities of ROS on Windows, no problem at all. And the best part about ROS-II today is that Windows is actually a tier 1 supported platform. So you can run ROS-II on Windows without any problem. And then the next question that we get is, what about safety in ROS? Well, implementing safety functionalities in ROS is not possible today, that we have to say. But on the other hand, you can separate the safety functions in a safety controller, as you would also do that, or as is actually the common practice in every robot controller, so that you split off the safety functions and run the safety functions in a safety controller. If you do not want to do that, then I think it's time to rethink safety principles and the standards that we have currently for safety. But that's a question for another day. And now let's take a look at all this and how actually industry has taken up ROS. So here at Fraunhofer IPA, we have collaborated with the company Bayer, for example, already starting in 2014 to build this kind of intralogistic solution for Audi. And this has been running at Audi for years now, for 4 years, I think, in total. And we are also actually collaborating with BMW to build the software for these nice STR robots. And there are many other examples. So for example, the company Mir is using ROS in their robots. ClearPath Robotics is actually using ROS in their robots. And there are many more examples like this for intralogistic use cases. And then you say, okay, what about manipulation in industry? Well, there we have, for example, the company DragonBot, that is a startup that actually has a no-code solution for robot programming, which is based on ROS. Or, for example, you have +1 Robotics, who creates actually advanced robot applications that are supervised by a so-called crew chief. A crew chief is a human, and this way they can actually team robots. So they will have a team of robots that solves an application, and once a problem occurs, the crew chief can actually take over and solve that problem. And we are also seeing the development towards companies really using ROS also directly, natively in their robots. So here, for example, we have a company Pils that is building a PRBT robot, or we have Resync Robotics that is building the Sawyer robots. And there are many more examples like that. And if you're not yet convinced that ROS has actually now found its way to industry, then take a look at the 33 videos that have been submitted to our video competition. And you will see that there are a lot of companies using ROS for development and also products. Yeah, just take a look at the videos. And now I think we can try and answer the question if we have succeeded in establishing an open source alternative to traditional robot programming. So in my opinion, yes, we have succeeded in establishing an alternative. But things can still be improved as usual, right? And we are facing a lot of new challenges and chances today. So for example, this year with the coronavirus that has hit us quite hard in the beginning of this year. And it was actually quite a challenge to keep the community going. But on the other hand, actually, the coronavirus was a very good thing for robotics, to be honest, because it showed that resilient infrastructures need intelligent robots. I'm sorry to say that, to be honest. And another challenge that we are actually facing these years is that, well, we are transitioning to ROS-2. For ROS-Industrial, that means that we need to port a lot of existing things to ROS-2. So that's actually the challenge. But the chance that we have in that case is that we are actually getting a lot of new functionalities like real-time capabilities or, for example, multi-robot collaboration capabilities. And what we are also seeing right now is, well, what I tend to call the rush on AI. So essentially, we see that the focus is really moving away a lot from software engineering and going towards AI. And especially we see that for funding from public sources. And even though AI is promising a lot of things, and I think can fulfill a lot of things, the thing is that moving this focus completely away from software engineering is a pity because necessary deployment structures for AI is actually based on the software engineering and, for example, ROS for robots. So if we want to leverage the new technologies that AI brings, I think ROS plays a key role in that, and actually that is also our chance. So we will see much more intelligent robots arising in the next, well, decade, I would say, and that is actually also a chance for ROS. So if you want to help us actually with making ROS better, if you're already developing with ROS, your contributions are always welcome to the ROS-Industrial environment. So if you're interested in contributing something to ROS-Industrial, you're always welcome to join our developer meetings. So these are actually every second Tuesday in a month, organized in turn by the European, the US, and the Asian branch of the consortium. So the times might shift a little bit due to, well, the different time zones. If you are not yet a ROS developer, but you want to start with ROS, then we have also an offer for you. So here at ROS-Industrial Consortium, we have different trainings for you. So one would be, for example, the ROS-2 developer training, which is actually or teaching you the basics of ROS, basics of navigation, manipulation, and also teaches you a little bit about best practices of developing robot software with ROS. So these are actually the dates for next year. If you're interested in that, just drop me a short mail. Registrations for the trainings will be published in January this year. And that is actually already everything that I wanted to tell you about. So thank you very much for your attention. And with that, I want to give over to my colleague, Carlos Hernandez from TU Delft, who's their assistant professor, and actually also the project manager of the ROSIN project, and he will tell us a little bit about ROSIN and what we have actually achieved in the last 4 years. So thank you, Carlos, and you have the word.
Thank you very much, Christoph. I think I'm sharing already my screen, right?
Yes, you just need to make it big.
Yes.
Great, super.
Thank you everyone for attending the conference and attending today. Thank you very much, Christoph, for a very inspiring opening presentation. I think I don't have to add much more because you basically presented the motivation for ROS-Industrial for this conference very nicely. But luckily, I have a presentation that is meant basically as a slide for people to check afterwards, mainly. So today, I want to explain a bit what we have been doing in this ROSIN EU project the last 4 years. So we were aiming at boosting this ecosystem, the ecosystem we have today in this conference. So let me, probably most of you know some of those actions or even have participated in some. Let me go through most of them or quite some of them. So first of all, before starting, Christoph was talking about pioneers. So let me introduce myself. I'm assistant professor at the TU Delft Robotics Institute in the Netherlands, and I'm the coordinator together with Professor Martijn Wiese of the ROSIN EU project. So in our department, so we have a clear focus. The challenge in robotics is the software and the new algorithms. So that's the focus of our new program. And this relates to the activities in education that we have been doing in ROSIN and why it is focused in this European project on ROS-Industrial. So apart from that, our research is targeting the high-level control architecture of autonomous robots. So mostly what you would implement in a ROS graph, basically with multiple nodes doing different actions. And we have developing this research in multiple European projects related to ROS-Industrial. For me, this started in Factory in a Day. So this is a Factory of the Future project where we started with working here in Delft and working with my colleagues at Fraunhofer IPA. And that was a great experience. And after that, well, we clearly identified the software as the challenge. So the whole idea of ROSIN started. On a more personal interest as a pioneer, I'm trying to apply new methods of knowledge representation and reasoning to adapt the control architecture of these complex robotic systems that we build in ROS, so as to increase reliability and autonomy. And you will learn more about this later in my presentation. But we are applying this in a main application area nowadays in the EarthLab Center in Delft. So this is one of these frontiers that Christoph was mentioning. We're applying this to operations in retail, but not only intralogistics, but at the store level. So this is, of course, very preliminary research together with Ahold Delhaize, a big supermarket company here in the Netherlands. And since January, we will be applying this in another frontier, which is underwater robots, together with some ROSIN colleagues, Professor Wasowski in Denmark. So I will explain later about this. But this is all the outcome of working in the ROS community. So I'm very happy to have stopped being a lonely pioneer during my PhD, to being part of this big community with a lot of initiatives in which you collaborate with each other to build new systems. So, but to stop about me, and so today I wanted to present briefly what we have done in ROSIN. And we have done this in 3 main lines of action, which we decided at the beginning of the project. The first one is quality assurance in ROS. The second is education in ROS. And then we had this cascade funding that we call focus technical projects that will be the main focus of today, not in my talk, but during the whole day, and expanding even tomorrow with some more presentations during the ROS-Industrial conference. So first of all, if you had in your agenda a lot of questions for contacts and networking, please feel free to use this time to do so, because that means you will be making the most of your targeted time today. If you are willing to know more or who to contact and what we will have been doing, then stay here and keep listening to my presentation. Anyway, for all of you, the slides will be available. So my purpose was basically to list and gather all useful pointers and resources for the community. So you can find them in our website, but here in the slides, you can have a nutshell of them. So if you are still here with me, instead of chatting with other ROS developers, let's go ahead. So an overview. So what was ROSIN? So ROSIN is standard for basically ROS-Industrial, but we were not allowed to use that name because we need a distinctive name for European projects. So we came up with this ROS-Industrial Quality Assured Robot Software Components as a overarching name for what we were doing, which is basically do ROS-Industrial in a European project. So we had 8 million funding from the EU as an innovation action. And we had two clear goals. The first one, and the ultimate goal, as Christoph presented for ROS-Industrial, is to speed up the industrial uptake of advanced robotic applications. And our means to do that was to build on the existing ROS-Industrial Europe community. And our focus was on making this sustainable, making the most out of public funding to consolidate an open source community that will advance beyond the time span of our project. So we gather a small but very committed consortium together with Fraunhofer IPA, including industry, with our colleagues from ABB and research centers like Tecnalia in Pays Basque, and other universities, the University of Copenhagen in Denmark, that was starting to work in robotics, but bringing a lot of software engineering expertise, and FH Aachen in Germany, which had a long story teaching and experience teaching ROS. But from the very beginning, and actually thanks to the Commission, we expanded our team together with other European projects that were working on what we have called the H2020 European Digital Industrial Platform for Robotics, and especially with our colleagues from Robomosis and Ofera, but also with good contacts with other projects like Robot Union, InBots, previous projects like RobotiTNet or the HORSE project. We have created a whole bigger initiative for robot software with European projects. So what was the departing point of ROSIN? So we departed with this past status, and now it's past. It was the current status 4 years ago of ROS worldwide community that was mainly for academic use and research use of the software. But there was little uptake in industry because they limited trust in that software. So we identified two main barriers or problems that we had to address. The first one was actually the quality of the software. Most of the ROS software were actually resulting from research project and was basically left unmaintained after demonstrating a research prototype. So there was a long path towards having software that can be reused by others, or even farther to be actually used in products. That was the first barrier. The second barrier is the prisoner's dilemma, is that a lot of industry were looking into ROS, but if no one was jumping into it, then no one was willing to jump too. So for everyone to jump, someone needs to go first, right? So we identified two ways or breakthroughs to break these two barriers. The first one was to start creating that high quality software. And for that, we will be investigating in the most effective methods from automated software testing, for example. And the second solution for the barrier of the prisoner's dilemma was to build that community. So create a sufficient user base so that it would be a self-propelling, self-sustained community. And we were going to do that with two mechanisms, by education and creating the community. And for that, we were going to be using more than 3 of those almost 8 million euros to invest in the community, to support developers creating ROS software for industry. So we had these two objectives. The first one, to assure the availability of high quality robot software. And I have to say, we have succeeded. So we actually demolish that barrier, and you will see how in the rest of the presentation. And we had as a second objective to create that sufficiently large European user and developer base. And I think, and today is the proof that we have also succeeded in demolishing that barrier. So as a result, I think, and we can see today, of these 2 days actually, that we have achieved a self-sustainable community of ROS Industrial in Europe and a strong contributor to the worldwide ROS Industrial community. So in the rest of the presentation, I'm gonna detail a bit about these 3 pillars that we have used to demolish these 2 barriers. The first one, create software quality assurance. The second one, education in ROS, both for students, but also for professionals. And the third one is this cascade funding that we have called focus technical projects to actually support with grants the creation of ROS industrial software. So first, quality assurance. And here I will detail a lot and add some links so that you can follow later on maybe potentially useful tools for you to use. So the key contribution regarding quality assurance in ROS from the ROSIN project, I think, was to create and establish the quality working group in the ROS community. So you can find this group in ROS discourse. So we have basically created a sustainable community body that is assuming the ownership of quality assurance practices and assuming that responsibility beyond the project. So this is already out of our hands, luckily. So the community is already responsible for quality assurance practices through the quality assurance working group. But we initiated this, and I can show a few examples of interventions regarding quality assurance that we did within ROSIN. So the first one was to create the quality assurance forum. So the beginning of this working group was this forum about quality assurance. And then we have, so that's where people can discuss about it and propose interventions, propose ideas for quality assurance. But we have consolidated the body of knowledge for quality assurance practices, like with tutorials, with articles in the ROS Software Quality Hub. And now this is also been maintained by the community. So there is an active community contributing articles, and I encourage, if you have best practices for quality assurance, to check and maybe contribute them also in the ROS Quality Hub. The second and very visible intervention we did was the quality badge for ROS-I and ROS-II, that is allowing developers to assess a package health based on trends of the continuous integration test results. Rather than relying on the most recent results, it looks now at the history of those results to have this badge with the quality of a package in the ROS wiki. And the latest that I wanted to mention was a contributing page to ROS-II, which addresses a very pressing community problem, which is that engineers that are willing to contribute in ROS, they don't know where to start. So we have implemented a new page in index.ros.org that lists open issues and pull requests where help is needed, or reviewers are invited to participate. But beyond those 2 interventions, we have also contributed lightweight tools and methods for programming and modeling ROS systems. And this is what I will explain in the next 2 slides. But if you have further questions or comments on this, please feel free to contact our leader on quality assurance, which is Professor Wasowski at ITU Copenhagen. So regarding the quality assurance lightweight tools, well, the ROSIN project started with an extensive analysis of quality problems in ROS at the level of ROS bugs. So as a result of this analysis, we have created a data set, a scientific benchmark for ROS bugs that you can find here in this link. And we have implemented ROS-I lint, so linters for ROS-I to find dependency paths. You can also find the code here in this repository. And we have integrated the HAROS tool for static analysis in ROS-I and supported its port into ROS-II. But this port into ROS-II has been developed already by a third party. So we are very happy to see that the community is already taking charge and responsibility in quality assurance practices. And you can find more information in this about HAROS tool in this repository. Another quality lightweight tools that we have been creating address automatic testing and simulation with model in the loop. So I'm not going to tell you more about this because my colleague John Chenkren from ABB will be explaining more at a very impressive demo that he will run at 11:30 today in room 1. So if you are willing to learn more about this, please join that session in room 1 at 11:30. One of the main findings in during our work in quality assurance is that sanitizers are a lightweight solution that can be highly effective in finding code defects in ROS components automatically. As an example, we found more than 200 errors, and you can find more information about this in this link. And we have been developing this ROS-II FAS, which is an automatic tool that takes an existing ROS-II node and stresses it with random text. This is known as FASing. So you can learn more about these techniques also today after our session at 11:15 in the software quality session from our colleagues Sulai Fu and Francisco Martinez from ITU Copenhagen in their talk experiences with FAS testing in ROS components. And the last tool that I wanted to mention is the ROS test generator, which is a very handy tool by Tecnalia, another ROSIN partner, to support ROS developers to write more tests and automatically generate the skeleton for those basic tests. So here you can find the link to that tool. Then tools related to programming methodologies and modeling. So we have been developing different approaches to ensure to facilitate quality assurance. So one is, for example, this RX-ROS, in which we have developed reactive programming API for ROS and ROS-II, and you can find more information in these two repository links. Our colleagues from Tecnalia have created a package generator which generates complete package and node code based on a given template. And you can also create your own templates to generate this skeleton. So this is a lightweight modeling approach that facilitates ROS development. And I wanted to mention yet another more researchy initiative. That's my pioneering work together with my colleagues in ROSIN, which is the meta-control for ROS-II systems, which is a solution to implement self-adaptation at runtime in ROS architecture that is based on architectural models and ontological, so symbolic reasoning and runtime on those architectural models. And this is to enhance the reliability and the autonomy of robots with a focus on quality of service for robot skills. So for example, how safe or how energy saving is a robot navigating. So this is an example of early research we did on safety for a mobile application. But we have been extending this to, with the support of ROMOSIS, the other EU project I mentioned, in a project together with BOS and Rey Juan Carlos University, Universidad Politécnica de Madrid, applying this meta-control approach to ROS-II systems. So you will be able to learn more about this tomorrow at 10:15. So this is not today, but tomorrow in the model-driven robotics track in room 2 from my colleague in the project, Professor Ricardo San. So this for quality assurance, now for education. And I will be very brief here because later today at 4, there will be a talk by Professor Stefan Kaveit from FH Aachen on on education in ROS and all the initiatives that we have done. So we have created a curriculum. We have trained more than 100 engineers in our ROS industrial trainings for professionals, which we call ROS academies. We have trained a lot of students in different ROS industrial schools. We have created a massive online course, and we have extended this thanks to the community. So we have helped others to create more ROS education that hopefully will be self-propelling. So courses that will be running from since actually last year and in the future years. You will learn more about this at Stefan's talk this afternoon. So please connect back this afternoon to learn more about ROS education. Just very briefly, regarding the massive online course that we created here at TU Delft, we have a new version after the success of the first version. And now we have upgraded it to ROS Melodic. That was last year, actually, already. We had 11 students registered. Actually, more than 900 were active following the course live. And we have an average of almost 400 now following offline on their own with a great rating from the course. And importantly, for next year, we are planning to support ROS Noetic and to have the course self-paced. So you can follow and do the exercises and get some feedback doing it self-paced. So not during the official run that we will do later. We are also doing trainings for professionals here in Delft at RoboHouse. And here you can find more information at the robovalley.com website of our center, our field lab for robotics at TU Delft. So as not to make this too long, let me jump into the most important aspects of today, and which is the focus technical project. So you will be learning a lot today firsthand from the developers of these projects for new ROS components. So I will not go through all of them. You can check them later. But what was this, for those that are not familiar with this? This program was a cascade funding program. So there was money from the commission that we have been using to finance open source development in ROS with a very concrete focus. It needs to be for concrete industrial needs. So we were supporting software that will contribute to the industrial or professional use of ROS in commercial products or in developments, but with a high TRL, basically, for industry. And we took the approach of funding only 1/3 of such projects because our idea was to foster. So not to give money that was not backed by industrial support, industrial interest. So to guarantee that interest, we were only funding 1/3 of the project, and the other 2/3 of the budget needed to be funded by industrial partners. So we limited this to a small, really small project, but the idea is to contribute ROS packages. So our size of a project was basically one ROS package that can be developed during a year, maybe departing from some preliminary work, of course, before. And we also extended this model to support ROS education actions that you will learn probably later today about them. So this funding was limited to the European context because this was money from the H2020 program in Europe. So all entities that were eligible for H2020 funding were eligible for our funding. So as I mentioned, today you will learn more about all these projects that you can visit in our website. So this is me just scrolling through all of them. There are 54 projects, so a lot of things to check. So probably you have some interest. You can check the categories and look for those projects. So I just wanted to mention that apart from our website, the most important place where all these projects are hosted is on GitHub or other repository systems online, open source, basically. So please go there and find the amazing packages that have been created. So to give some numbers of this, so we received over 80 applications. So actually, we were very happy to see that almost all the applications were very targeted and excellent applications. That's why we funded a lot of these projects. We funded 57, I think only 54 were completed in the end, which is an amazing percentage. And we granted overall more than 3 million ourselves. So that means that we boosted 9 million investment in ROS software, because the other 2/3 were being funded by the participants in these projects themselves. So our projects were well spread all over Europe, European Union countries. We had a lot of diversity, but we were very happy to see that most of the champions, so the leaders in these projects, were companies with industrial interests. Drivers makers, or well, mostly system integrators, which we all know are the main users of ROS. But we also have research centers and only a small percentage of companies that were working closely with industry. So we were happy to support also this synergy of industry and universities with a focus on practical industrial applications. And we were very happy to see the diversity of projects, of packages created, not only hardware drivers, but also ROS enhancement proposals, new algorithms, but also application templates, security audits, documentation, tutorials, code reviews. So we were very happy to support a lot of different initiatives that are actually needed in the community. So as I mentioned, for you, I think the most interesting thing is to learn from this focused technical project. So please reconnect later today in the afternoon for the track on visualization tools. There will be 4 projects funded by ROSIN talking about that. In parallel, unfortunately, there will be the security track, where you can also learn from Alliance Robotics about cybersecurity in robots. There will be 4 more on industrial tools and libraries from these 4 projects. And later, till the end of the day, about planners. So some packages about planning from our FTPs. So please stay tuned today, because you can learn a lot, and probably there you will find a lot of useful tools. And please connect to discuss about the best practices and what are the next challenges, how to contribute maybe to extend these packages. Finally, so this is not over today, but tomorrow there are also focused technical projects presented in the control of path planning, and unfortunately also in parallel in the model-driven robotics. This was another project with our colleagues from Romosis, the Papyrus for Robotics. It's another model-driven tool for ROS too. So these were basically the activities we have been doing and how they are visible now. So as a result, we are proud to say that there are now more industrial applications visible. And actually, there were quite some that were not that visible. And I think now we brought or helped bring to the surface a lot of industrial use of ROS that was going on under the hood. So in our project, we were aiming to boost the ROS and the ROS software from lower TRLs in academic use into the higher, so up to TRL 7. So real prototypes in an operational environment. So please check later today at 11:30 the industrial applications examples that our colleagues from Tecnalia and ABB will be demonstrating in room 1. And also tomorrow, the video competition that Christoph and the team at ROS-Industrial Europe and from Hoover IPA have organized to see some really amazing applications of ROS in industry, and later more ROS industrial applications at the track at 3:15 tomorrow. Another result, so we were creating this synergy with other European projects, right? So I can proudly say that together with Ofera and the Romosis projects, we have been working together in a lot of small projects around ROS and the model-driven. So these are some examples of those projects. And this is probably continuing afterwards. And will continue, as I mentioned, also in this Remaro project that ITU Copenhagen is now coordinating. So this is a Marie Curie network for reliable AI for marine robotics. So this is the underwater frontier for ROS. So we have a consortium with submarine experts and software reliability experts and a marine safety certification agency that will educate 15 PhDs in a unique training program to realize this vision of reliable autonomy for underwater robotics. So in this network, we will collaborate to address some of the challenges that we have identified during the ROSIN project. So we will be focusing on developing AI methods for underwater robots, but with quantified reliability, with correct specifications, model tests, and analysis and verification tools to guarantee this trustworthiness that Christoph was mentioning. So, and with this, I conclude my presentation. So as a result of ROSIN, I'm happy that we have contributed and helped the ROS community to advance in quality assurance with new methods. We have fostered the education in ROS, and we are happy to see that widespread now around Europe with a lot of trainings available by other parties. And we have helped and supported the creation of more open source ROS software that we see now self-propelling with a lot of connection in between different people that were doing this more as lonely pioneers, and hopefully now they have more of a network and community support. And as a result, we can now see a lot of ROS industrial application. And this is not the result of ROSIN. I think ROSIN has put one additional stone to build all this together with the ROS industrial community, which has been the bigger driver for all this. So hopefully now we are in a position in which ROS Industrial Europe is a sustainable and growing community that will be key for this European digital industrial platform for robotics. So for more information, please contact me, and most importantly, Christoph, that is the manager of the ROS Industrial, and this is what will be alive after ROSIN ends this month. And I would like to thank a lot the ROSIN team that has put a lot of effort. So we have started 4 years ago, puzzling how to put all these pieces together, including our own consortium, how to work together on this. And I think we have greatly succeeded. We had a lot of amazing and very fruitful meetings, first when it was possible in person, but even now this year, struggling with the pandemic, we still had very amazing meetings, and I'm looking forward to connect to them and to the broader community during this 2 days conference. Thank you very much.
Thank you, Carlos, for presenting. Yeah, thanks for the many information, and yeah, it was a really pleasure working on this project. So I think we can start into the question session more or less. All right. So one question that came, Carlos, and I think you can maybe answer first, and then I can answer afterwards, was mainly related to, okay, you showed a lot of ROS-I applications, and hasn't there been yet a major shift to ROS-II? So what is your opinion on that?
Well, I think it's really good that there is a lot of uptake of ROS-II. I think ROS-II is a platform that for some applications is needed and will actually is key, so that ROS is applied in some very specific applications. But I think ROS-I will also live for quite some years. I think there is a lot of community, there is a lot of good practices, a lot of good software that, as you mentioned before, can meet the requirements for many applications. So I think ROS-I and ROS-II will be coexisting, but who knows how this evolves. This changes very quickly. But I seeing the previous trends and how is it in the community right now, I think we can have a very successful coexistence of both.
Right. Yeah, I think actually the same. So currently, I think we are at the stage of coexistence. On the other hand, yeah, we showed a lot of examples, but I think ROSIN project also has a lot of activities in ROS2. So we actually also helped fund Move-It2, helped fund ROS2. You will see a lot about that also, ROS Control 2, sorry. You will see also a lot about that in the next 2 days. So yeah, we have, we are currently starting to build up the necessary infrastructure to really use let's say ROS-Industrial code on ROS2. So currently you still need to have, for example, robot drivers running in ROS1 and then use a bridge, but that there's also an effort ongoing right now to build robot drivers that are run natively in ROS2. But for that, we actually first need a ROS2 control as well as Move-It control to be able to do everything there. Right. I think we have another question.
There.
So
yeah,
one question.
Whether
go on.
I'm seeing will there be a ROSIN too? That's really tough, and it's probably for the European Commission to to answer. As you have pointed out, Christoph. Now everything is AI. And I think where the focus is, I think partially, unfortunately, shifting completely. I mean, it's of course really good to have that focus, but I also see the problem neglecting the software aspects in robotics. So I think there will be many ROSIN 2s. So Remaro will be a ROSIN 2 project. We are going to be addressing quality assurance in ROS for a complete application for underwater. So I can see how ROSIN hopefully will spread into multiple European projects in the upcoming years. I see it a bit difficult to fund another project that is completely focused on ROS, and this is just personally. I think for those people that are thinking of creating a European proposal, I think the way to go is Remaro sets an example. Pick a challenge, an application area that is aligned with the Horizon Europe, the new program that just went live last week, I think, or a few days ago. So pick one of those challenges, pick one application area, and develop your research in that context, and make a proposal in that area, and you can still advance, or you should advance ROS in that sense. And I think in Remaro, for example, we will be doing a lot of work that will contribute to the ROS community in there. So I see how this can result in multiple projects, picking the right challenges for the funding.
Yeah, and I think from the, let's say from the ROS-Industrial perspective, I mean, we have the tools there to also fund these kind of FTPs, but I mean, fund them commercially. So that's essentially the goal here, that we kick off more and more projects that are completely funded by companies. And I mean, the first step to that was actually also ROSIN, because also there we had only a funding rate of 30%. So to be honest, that wasn't that much. Yeah. Right, we have another question ongoing, which is about the main advantages of using ROS. Carlos, do you want to go first?
Okay, well, I think the big one you explained very nicely at the beginning is to move from the lonely pioneer into community, basically. I think that's the main advantage with ROS. ROS, of course, provides a lot of very nice software, common interfaces, which is very important. But if I have to choose one value of ROS, is that community, basically, because with the ROS community, you basically make that happen. So there were a lot of approaches to create very nice robot software with standard interfaces. But if you don't have the community, like you are not you don't manage to work together with most of the people out there, then it doesn't pick up. And I think that's the main value in ROS right now. There is a very lively, committed, and supportive community for the pioneers, and there will be less lonely joining that community. So that will boost their development and what they can achieve. Basically, I think that's the main value.
Yeah. So that's also my opinion, to be honest. So I don't want to add on that. I think something else that we can go into is a little bit. Okay, we've asked the polls, and I mean, what came out now is that actually most of the people are still thinking that software quality is the main challenge for using ROS. Well, so from my opinion, I would say, okay, yes, that's true. So it's hard to have reliable numbers and KPIs on that in the open source ecosystem. But I think we did a lot in ROSIN to improve that. With the bugs program, with the quality assurance group. But I think we can do more. So most probably, Carlos, with your experience in model-driven robotics, you can say a little bit about that.
Yes, so I had the experience now live working less as a pioneer, but with other people on how important modeling, and it doesn't need to be formal modeling, but modeling your problem. So getting to communicate what is the application you are developing, what are the requirements for that applications, what is the architectural solution that you have in mind, so as to implement that. I think those practices are very valuable and can really contribute to the quality of the software developed. Because at the earliest stage, when you start designing, that's when you make the implicit agreements on what are going to be the interfaces, but not only the interfaces, but the behavior expected in your system. That's not reflected entirely with the interfaces. So if you don't model that, well, people end up going through the code, running and executing. And that's very nice when it's a small package and we all enjoy hacking and reverse engineering. Oh, that's how it works. But I don't think that's scalable. The moment we integrate really big applications, and I think you at IPA have a very a great experience with that, with the CareRobot robot, with other big systems, and you know the value of modeling there. So with this ROS model that Nadia and other colleagues there at IPA are creating, that's the only way to actually have an overview of very complex systems. So if we don't have that tools, it's really hard to increase the quality in systems that are very large, basically. I don't see a way around. We need abstractions to simplify, to be able to cope with that complexity. And modeling, I think, provides for that abstraction. That's the important aspect. The abstraction it provides to be able to communicate from the early moment with the requirements to the integration of the packages and how they fulfill or not those initial requirements, basically. I think that's key, and I was very impressed with the work you guys were developing at IPA to be able to model ROS-based systems, basically. And I'm hoping that continues into ROS 2, basically.
Yeah, I mean that was born from the development of the CareRobot, where we really integrated a huge system with a lot of different computers and nodes running, and that really showed the necessity of this. And I mean, the big thing that we have in using ROS is that we are not building like simple applications, as I said before, that we try to pick and place the same object all the time from one place to the other or something like that. But we're really building complex applications with a larger degree of complexity. And I think model-driven approach is a very good approach. I mean, the next approach that we are now looking into also is AI for these problems, where we then, let's say, more or less hide the complexity behind the network and hope that the network understands the problem better than we do. Yeah, so I think there are a lot of solutions there.
That's a very interesting idea, maybe for people into AI here listening. So AI is very much needed in modeling to be able to manage that, as you mentioned. So that could be a very interesting European project, for example, if someone wants to develop that AI methods to support modeling and development of ROS systems to cope with that automatically. To deploy automatically safety patterns, for example, in your architecture, and then deploy the code. This kind of things. Yeah.
All right. I think we have time for a last statement, I would say. So I think we had the polls running, and Carlos, what we see in the polls actually is that we have a lot of users already. Well, around 75% already using ROS. And we see also that 84% are planning to use ROS for product development. So that, I think, is quite a thing. What do you think about application areas? So where do you see the biggest, let's say, the biggest potential for ROS?
Actually, I think it's a tough question, because I think ROS is meant for any robotic application, right? So I think the moment the system reaches a certain complexity, then you need something like ROS, a component-based software to deploy it. So of course, there are maybe some applications that are still a bit far from ROS reach, like I don't know, aerospace applications with very strict requirements. That used to be the case, but with ROS-2, I think there is a potential also in those kind of applications. And I'm mentioning this as the ones that are far reach, because I think for all the rest, yeah, I think maybe except for those with strict real-time requirements, for which the methods and the tools are yet to be developed, there is already a big raw tool, which is ROS-2, to address those challenges. Now we need the methods and the practices to deploy in those kind of systems, basically. But for other applications, I was surprised. Thanks to our FTP program, we discovered people applying ROS even in really old school automation systems, for example. And they were a very small company in Barcelona deploying those. That was completely unknown, I think, for many people, that you can actually do that, but you can. And they actually contributed a very nice driver for motors used in traditional automation. So yeah, the reach of ROS technology, I think, is very broad. It's hard for me to say one application area that is going to be okay. ROS is going to be in there. Now there are connections also with cloud computing, and so I don't know, Christoph. What do you think? You have probably a more industrial overview there at Fraunhofer.
Well, I think yes. So manufacturing has a lot of spaces where it can be very well used. But there are many more application areas that are popping up. So tomorrow we are also going to hear from agricultural applications. We know already that warehouse is a big application sector. So I think there are a lot of possibilities out there, and it's difficult to answer that question, to be honest. Finally, thank you, Carlos, for the presentation. And so I still need to answer one question. So there was a question towards where can I find the slides and the videos. So essentially the slides, we will publish them on the ROS-Industrial homepage a little bit after the conference, because we need some time to go through them and make sure that everything is publishable, right? And the videos, we are going to upload them probably in January, February. So we need a little bit of holiday time. But after that, the videos will be freely available for everyone. That's all from our side. Thanks for joining in, and I hope we see you in the software quality session right after. Thank you, guys. Bye.